Hello, EDS 6120. I'm just here to review question number 7 from the pretest. I did add a document on the module for week 6 with the solution to this, but just in case you want it step by step, here I am. All right, so we have parallel lines, A and B. Okay, I'll make the lines a little darker. Usually the letters written lowercase to represent the lines. All right, once again, this is number 7 on the pretest. And basically, it's more 7th grade Common Core standards here. You don't really see this in 8th grade, but it really helps them prepare for geometry class. So we're given some points, A, B, and C. And then down here, D, E, and F, and G. Okay, and then we have a line coming down. It looks like a line segment. Technically, we can extend it. Okay, but here's our line segment, and we can extend it going down. We can just pretend it's there. It's not really there. When you have something passing through two parallel lines, that's called a transversal, and it helps us establish some relationships between the angles. So for example, now I have, as you can see, 8 different angles here. 1, 2, 3, 4, 5, 6, 7, 8. I can actually say that angle 1 is equivalent to angle 4, right? Because they're opposite. These are called vertical angles, all right? There's a whole bunch. So angle 2 is equivalent to angle 3. We're talking about the measurements. Angle 5 is equivalent to angle 8. And angle 6 is equivalent to angle 7. All right, we have exterior angles being like outside, right? We have interior angles being inside. We're going to focus on those. Your interior angles here are 3, 4, 5, and 6, right? So we can establish alternating interior angles, things that alternate, so they're not next to each other, because 3 and 4 are next to each other. They're interior, but they're not equal to each other. 3 obviously is more obtuse. I think it's obtuse compared to angle 4. What is the relationship between angle 3 and 4? Well, if you add angle 3 plus angle 4, you're going to get a line. So angle 3 and angle 4 are what we call supplementary angles. They will add up to 180. Anything on a line is supplementary. Anything on 90 degrees is called complementary. So if you had an angle here, A, and an angle B, angle A plus angle B will equal 90 degrees, right? So that's, you see, complementary. And none of this, is in that 8th grade workbook, because once again, these kind of things are mentioned in 7th grade Common Core. All right, so interior angles are 3, 4, 5, 6. 3 and 4 are not equal, but 3 is equal to angle 6. And because they're not on the same line, they are alternating. So they're alternate interior angles. Bad handwriting. So alternate interior angles. Angle 3 equals angle 4. And what's another one? Oops, sorry. Angle 3 equals angle 6. My bad. All right. And what's another one? Angle 4 is equivalent to angle 5, whatever's opposite to it, right? Or alternating it. Okay, so if you want to look up exterior, you can. I don't think you'll need that for the homework or the pretest. I don't think the post-test. All right, so I'm going to erase these angles because that's not part of the pretest question. basically you have a triangle in this, and you need to find out one of the angles. Okay, and since, once again, we're able to extend this line segment up, we can call it, transversal, and therefore we have these relationships, all right? So we have one more point called H in here, and that's connected to E, so it's line segment EH. And your goal is to find the measure of angle DEH. Angle DEH is here. All right? We don't know it. We only know two pieces of information. CBH is 70, and BHE is 105. All right, so given that, as I had mentioned in the solutions that I typed up, we just need to find out what this is. If we find out what FEH is, then we can subtract it from 180 to get the remainder of DEH, because remember, these two angles are on a line, they're supplementary. So our goal is to find out this in order to find our answer, all right? So to find out this, we see there's a triangle, and we know that all these three angles somehow add up to 180. Now, I've had students kind of try to measure them out physically, and I tell them, these are not all drawn to scale. So even if it looks like, it's 30 or 50, it might not be. So just go with what, the calculations say. All right, so what do we know? Do we know anything? Well, we see here this is 105. This is 105, but it's on a line. So given the supplementary angle theorem, if this is 105, that means this that's connecting it to this line has to be 180 minus 105. So we do some subtraction or use our calculator, and we get 75. All right, so that means angle EHF is 75. So we have one piece of the puzzle. Remember, there are three pieces here. We need to find this one where angle F is, and this one where E is, okay? So we know that the sum is going to be 180. All right, now we use what we talked about a few minutes ago with the transversal. This tells us we have alternating interior angles. Alternating interior angles. We don't have numbers on them, but we have, this one here is equal to the alternate down here. Now this one here is equal to whatever's alternating on it on this line, which is here. And that's one of our missing pieces. So let's go ahead and say if this is 70, then this must be 70. And just to extend it, if this is 70, this is 110. So if this is 110, then this must be 110. But we don't need to know that, right? That's just extra information. All right, this is really shaping up. We have 75 degrees, 70 degrees, and now HEF or FEH. We don't know what it is, but we know it's going to be what? It's going to be sum of this subtracted from 180. So 75 and 70 make 145. You subtract these two from 180 because it's a triangle. We get 35. So this acute little angle here is 35. Almost done. We wanted DEH. DEH is on a line supplementary to HEF. So therefore, 180 minus 35 will give us our final answer, which is 45 degrees. The measure of angle DEH is approximately or equivalent to 45, right? And that's how you solve number 7. Okay, hope this helped.